Simplest polygon is a triangle, three-sided shape. But polygons can be of all types and all numbers of sides. And they can be regular, having same length sides, and interior angles all the same, or they can be irregular, so their sides can be any length and their angles can be of any size. Whatever type of polygon it is, there are links between the number of sides that a polygon has and the interior angles of those polygons. So let's have a look at some examples. Let's start with a triangle. A triangle has three sides, and the sum of the interior angles, and I'm sure you know this one, is 180 degrees. That's fairly straightforward. Everyone knows that a triangle has interior angles that add up to 180 degrees. Then we move on to a quadrilateral. In this case we're using the square. The interior angles of a quadrilateral, all four corners are 90 degrees, so the interior angles add up to 360 degrees. Moving on to a pentagon. If you get a pentagon, a regular pentagon, measure the interior angles, you'll find that those interior angles add up to 540 degrees. That's 108 degrees for each of the interior angles. In an irregular pentagon, of course, obviously those angles can be different. And we can work through each of these different polygons, and we see that for a hexagon it's 720 degrees the interior angles add up to. For an octagon it's 1080 degrees, and for a decagon, 10-sided shape, it's 1440 degrees. So you can see that as we are increasing the number of sides, the interior angle sum is increasing. It's also true that the average angle is increasing as well. Starts out at 60, then goes to 90, then goes to 108, then goes to 120, and so on through the list there. But it would help us if there was a connection between the number of sides n and the angle that we get. And you're not going to be surprised to hear that in fact there is a well-known connection between these two things. If we take the formula n minus 2, so that's the number of sides minus 2, and times 180. We see how that works for the triangle, obviously. 3 minus 2 is 1, times 180 is 180. What about the quadrilateral? 4 minus 2 gives us 2. 2 times 180 is 360. We could go on and look at each of these shapes in turn, but we'd see that that formula works. So let's write that down so we don't forget it, and then we're going to try and solve an example using this piece of information. So on this diagram we've been asked to find angle Z. But in order to find angle Z we need to find angle Y. In order to find angle Y we need to know what angle X is, and we work backwards. So let's start with angle V. That seems like a good place to start because we've got a straight line there. We know that angles on a straight line add up to 180, so angle V is 180 minus 80, which gives us 100. We can also use the same principle to find angle W. W and 80 lie on a straight line, so W is also equal to 100. Now we have 4 of the 5 angles inside an irregular pentagon. Using our little formula we've written down, we know that the angles inside a pentagon is equal to 540. So we can work out by taking away the 4 angles we do know that X is equal to 125. Again, we can work out Y because Y and 125 lie on a straight line. So Y is 180 minus 125, which equals 55 degrees. And finally we've got a triangle. Triangle, all 3 angles add up to 180 degrees, so Z is equal to 180 minus 80 minus 55, which equals 45 degrees. So at the beginning of this question there were 8 angles and you only knew 3 of them. And by using the 2 simple rules, angles on a straight line add up to 180, and the formula that tells you what the angles inside a polygon are, you were able to work out what each of those angles were, one by one. Quite often you will face questions of this kind where the angle you're asked for is not immediately calculable, but you have to work through and get the angles that you can work out before you get to the one that the question is actually about. As always, take care to make sure that you write down what you're doing as you go along. Don't try and memorize any of these angles. Write them down. You're less likely to make mistakes.